Okay, hello. How are you? Um, so this is another session, Module 7, CCNA 3, wide area networks concepts. And in this one, we'll discuss basically the type of connections that we have in wide areas, from the traditional ones to the modern, then lastly to the internet-based connectivity options. So the module objective is to explain how WAN access technologies can be used to satisfy business requirements. I think at this point, we are all familiar with local area networks. How do you design? How do you set up? How do you install? Basically, how do you come up with a local area network? But if you now have multiple local area networks and they need to be connected, there is need to have a wide area network. And that is basically what we are going to be focusing on today. Purpose of WANs. So we start by defining and differentiating LANs and WANs. By definition, a WAN being a telecommunications network that spans over a relatively large geographical area and is required to connect beyond the boundary of the local area network. Now, WANs are used to connect geographically separate local area networks. So I'll give an example. Probably a small company. When it starts with one branch in Harare. Excuse me, in Harare, you have a local area network there. You're operating from there. If you need to connect to the internet, you connect to the internet from your one small branch. But if the company grows, it means you might require another branch in Blawayo. And if you want to connect your Harare and your Blawayo branch, not over the internet, but probably a dedicated link between those two branches. That is what we call a wide area network. That is one example. Obviously, the internet is another way of connecting those two branches, but for huge enterprise networks, if I can say, the dedicated or the leased lines are more preferable. So you will not be using the internet, but there is a dedicated connection between your two branches in Blawayo and Harare. And that is what defines a wide area network. Now, to put it into perspective, you will see what we call a wide area network is not only the link. We might say the link, but there are a lot of things there. There is the link itself, let's say the media, which connects the two branches. Then there's a couple of network infrastructure devices as well. Your routers, your switches, probably layer 3, and your huge routers, which are connecting those two branches. So when we talk of wide area networks, it's not only media that we're talking about. It also includes the networking infrastructure that connects the two branches. The data centers, you might need a data center to connect your two branches, and that is what defines what we call a wide area network. There we also have the differences between local area networks and wide area networks. I think those are small. The lines provide networking services within a small geographical area. They interconnect local computers, wireless to WANs interconnect networks. A LAN is owned and managed by an organization. A WAN can be owned by service providers. Mostly is owned by service providers. Other than the network infrastructure cost, there is no fee to use the line. WAN services are provided for a fee. Why? Because of the infrastructure, because of the cost of setting up that wide area network. That's why there is a cost of using a wide area network. LANs provide high bandwidth speeds. WANs offer low to high bandwidth speeds over longer distances. Then for LANs is over short distances. Right, private and public ones. A private one is a connection that is dedicated to a single customer. The example I just gave of two branches in Harare and Bulawayo, that is a private one. And it's a connection that is dedicated to a single customer. If we talk of the internet, we don't talk of single customers when we talk of the internet. That is a wide area network, but now it's public, right? So with private ones, we have what we call service level agreements, which define the bandwidth that you're going to be using. The standards, it basically says the standards of the type of connection that you're going to have. If the standards are below, it means basically you've reached the agreement. I'm not so sure what happens after, but if those standards are breached, it means your network is not working up to the expectations. So with private ones, we have guaranteed service level, consistent bandwidth, and security. With public, it's not guaranteed. With the internet, sometimes the internet is down. That is not guaranteed. So I think you cannot negotiate SLAs with the public networks, unlike the private networks. A public WAN connection is typically provided by a service provider using the internet. In this case, the service levels and bandwidth may vary, and the shared connections do not guarantee security. All right, so basically, that is the difference between private and public ones, with the private one being dedicated to a customer, and the public, the best example being the internet, that is a shared network. All right, WAN topologies. So we're going to discuss 1, 2, 3, 4, 5. All those 5 WAN topologies: point-to-point, hub and spoke, dual home, fully meshed, and partially meshed. Not large networks usually deploy a combination of these topologies. Right, the same thing with local area networks. I think we discussed local area network topologies. Star topology. I think that's the most common. The mesh is also there. I remember bus topology. I think there's still a few that are missing, but those were the topologies which were used and which were ideal for local area networks. And these ones are more ideal for wide area networks, starting with the point-to-point. So point-to-point, it employs a point-to-point circuit between two endpoints, involves a layer 2 transport service through the service provider network. It is transparent to the customer. Right, with point-to-point, let me see. With point-to-point, basically you have 2 points in a network which are connected together. When I mentioned those 2 branches, there is a direct link probably between the router, which is at one of those branches, and with the other one. The problem with this type of connection, however, is very expensive. It's very expensive, and it has limited scalability. You cannot scale the network because if you add multiple links, if you add multiple point-to-points, therefore the cost becomes too much. So this one, for large networks, if you want to have a very large network, it's not a very good topology to use. I think there are far better ones that we're going to look at. Let me see. Hub and spoke. Now, this one enables single interfaces on the hub to be shared by all spokes in the circuits. So if you look, we have a router which is called the hub, right? And then we have ABC, these are the spokes. So instead of having a direct connection, like the point-to-point, with this one, this is typically your service provider, this hub, right? We have the service provider which connects to different sites. So this can be site A, site B, site C. So instead of having point-to-point links, this is sort of a point-to-multi-point, but it also has its disadvantages as well. The hub router represents a single point of failure, and if it fails, interspoke communication fails. So if this link fails, or if this, I can say ISP, if it fails, therefore there is no connectivity at A, B, NC. But basically, that is the hub and spoke topology. Dual-homed topology. All right, with this one, so this is a configuration where we have a device connected to two separate networks. So if you look at A, I think it still looks like a hub and spoke, but instead of having one hub here, we have two. So if you look at A, it is connected to this hub and this one as well. That's why it's called a dual-homed topology. So by definition, a device is connected to two separate networks. Why? This greatly improves reliability, redundancy of a network. The problem, however, with dual-homed, let me see. Okay, it is more difficult to implement because they require additional and more complex configurations. Expensive as well, because you're connected to two different ISPs. If you are talking in terms of ISPs, you're connected to, okay, let me not confuse dual-homed and multi-homed. With dual-homed is one ISP. So this is one ISP, but with two links. We're going to look at dual-homed and multi-homed, I think, at the end of this lesson. So dual-homed and multi-homed are not to be confused. With dual-homed is one ISP, but two different links. So this is the same ISP, but this is link one, this is link two. If link one fails, link two is up. But if the ISP fails, then you have a problem. And that is why we have multi-homed type of topology, where this one is one ISP, then this is a different ISP. So two connections with two different ISPs. I think let's cross that bridge when we get there. Dual-home topology. Then we are fully meshed and partially meshed. These ones, the fully meshed one is the most fault tolerant because every network is connected to every other network, fully meshed. With partially meshed, it's not all the sites that are connected to each other. And I think the huge difference, why I have partially meshed, why I have that, it's more efficient. We have, for example, if I'm looking at my network, and these are important servers, site C, site A, and site B. They are very important servers there. That is the reason why all those sites are interconnected. They are all connected to each other. But if there is nothing important at site D, why have site D connected to every other site? There is no need for that because we don't have important infrastructure, important information coming from site D. So that's the reason why we have partially meshed topologies, because they are more efficient. They are more effective, if I can say, cost effective, more cost effective than the fully meshed topology. Right, topology is done. Now we're looking at carrier connections. By definition, a carrier owns and maintains the physical connection and equipment between the provider and the customer. The service provider may not or may be the actual carrier. Right. By definition, what is a carrier? So a carrier, these are the physical and logical connections between different telecom networks. And it consists of quite a number of nodes, your POPs, point of presence, your COs, the media itself. So the carrier is sort of the physical infrastructure which is responsible for transmission, if I can say. That's the carrier. A perfect example, taking where is it? The service provider, right? Taking this point here. The service provider may or may not be the actual carrier. I'll give you an example of, I think, Tier 1. Tier 1 is probably the biggest carrier in Zimbabwe, and it carries, if I can say. Probably Econet, it is riding over the infrastructure of Tier 1. So Tier 1 is the carrier, but Econet is the service provider. I think Econet is also using Liquid. I'm sure Liquid's fiber. But I think the perfect example of a carrier and a service provider, internet service provider, Tier 1 is the carrier, Econet is the service provider. I think at this point, Econet also has its own infrastructure, but I don't think it's independent of Tier 1. Tier 1 is also a service provider. So in that case, it is a carrier because it has the infrastructure. It also is a service provider. So those are two different things, being a carrier and a service provider. I cannot pinpoint examples of companies which are carriers only. I'm not so sure. Probably Liquid, no. I think Liquid it is so now. So it is a service provider. I'm not so sure. But there should be companies which are only carriers and not service providers. Right? Typically, an organization will choose either a single carrier or a dual carrier. So I think this is the same thing I was trying to explain with dual homed, almost the same thing. So if you're using a single carrier, no problem. It's less costly, but if this links shuts down or if the ISP provider is not available, then for a huge company, that's a problem. So for a very huge company, you have two service providers servicing your network. So if one shuts down, then the other one is available. Right, a single carrier connection is when an organization connects to only one service provider, and SLA is negotiated between the organization and the service provider. So evidently, with two service providers, you have two different SLAs being negotiated. All right, we have a question in the chat. Transmedia. Voila, thank you very much. Transmedia. I think transmedia is a perfect example of a carrier. But which service providers uses transmedia? Is it not for broadcasting? You're very close, but I'm not so sure. I think transmedia is more on broadcasting. Do we have any service providers using transmedia's infrastructure? I'm not so sure. Yeah. But that was a very good shout. All right, carriers, klar, done. Let's move. Evolving networks. Network requirements of a company can change dramatically as the company grows over time. A network must meet the day-to-day, someone in chat, carrier for broadcasters. Okay, it makes sense. So it's a carrier for broadcasters. It makes sense. Right. A network must meet the day-to-day operational needs of business and it must be able to adapt. Network designers and administrators meet these challenges by carefully choosing network technologies, protocols, and service providers. Networks can be optimized by using a variety of network design techniques and architectures. So we are going to illustrate an evolving network using that small company called Span Engineering. And we're going to demonstrate as it grows from small local business into a global enterprise. So we want to see uh, what do network designers, what do administrators do as the network evolves? As the network evolves, it starts small. There we have our small network. Right, it starts small. Typically we have, I think I can see 2 employees there. Probably we have less than 10 employees. So for that small network, how would you connect to the internet? All right, it's very simple. I can see we have a wireless router here. So those guys, they connect to via the wireless router. Then we have the modem. Then from the modem to the internet. So that is a very simple setup. All right. And for this broadband access, typically, I think in this example, they were using DSL. We're going to go through all those type of connections later on. So for this one, they were using DSL. That's a small network. Okay, small setup. But if that network grows, quite a number of things change. We now have a campus network comprising of a number of local area networks. So you can see we have a network here for marketing and sales, finance, accounting, engineering, and production. So instead of having that small wireless router and a modem, we now have a firewall. Okay, we have routers and firewall. And from there, our DSL is probably here connecting to the internet. But as the company grows, probably we might not need to use this DSL. At some point, we will choose fiber because of its capacity. So depending on the number of devices we have here, the number of traffic we are pushing, it also affects factors. It should be factored in when choosing the type of connection that we have here. Campus network, then from there we have the branch network. Instead of having one campus, we have multiple campuses, multiple branches. They all need to be connected. How are we going to do that? The company now requires a metropolitan area network. So I think in terms of size, we have the local area network, the metropolitan, then the wide in terms of geographical size. So for branch networks, we now require a man to connect to the central office, branch office in nearby cities, use private dedicated lines through their local service provider. So we now have dedicated lines here from every branch office via our service provider, then to other branches. So this is typical service provider, this one. Okay, here they were using the public one, the internet, but these links, they are dedicated. So they are exclusively for these offices. When we say dedicated, it's exclusively for that. It's not a shared network. I think some of these things we'll explain as we go. For the distributed network, now we have offices in different regions. How are we going to connect those offices? So we came from DSL for the small network, probably DSL fiber, direct links, point to point, no problem. But can you have a point-to-point link from here in Africa to the United States? I bet no, you cannot have that. So you need a different type of connection. And the most popular one being VPN. You'll be using the internet, the public network, create a tunnel over the public network, VPN, site to site, will connect your branch offices, encrypted traffic, and voila. So you can see as the network evolves, as it grows, different technologies are being used depending on how big the network becomes. Small campus, branch the network, probably metropolitan area network. Then from there, we have the distributed network, the bigger one, connecting regions. And the technology we are using at this point is VPN. We can have other technologies besides VPN, but they will be very costly. VPN is cheap because it rides over the infrastructure of the internet. Right. One operation, one standards. More than one standards are defined and managed by a number of recognized authorities. Okay. I remember CCNA 1, I think it's module 3. I think it had some of these organizations when we were doing the OSI models. Okay, the standards that we have here, which manages wide area networks, we have TIA or EIA, Telecommunications Industry Association, and Electronic Industries Alliance. So this one is mainly responsible for developing standards for cabling. I know for cabling, we have standards which are used for cabling. Then we have standards which are used for data centers. The type of cabling that you are going to have, I think it's called structured cabling. How do you cable? You have a building. How do you put your cables? Where do you put your cables? There are standards for that. And those standards are defined by the TIA/EIA. Then we have the IEEE. I'm more familiar with IEEE. And that one is responsible for standards in a number of areas. I know of Ethernet. I think it should be IEEE 802.3. I know of Wi-Fi 802.11. I know of personal area networks, wide personal area networks 802.15. There are quite a lot. Uh, and now cream. I don't have them from the head. I know only those three. So IEEE is another organization responsible for standardization. Then we have ISO, International Organization for Standardization, and that one is mainly responsible for standards which ensure safety. Safety. I haven't encountered much in this side of networking ISO. I know engineering side. When they talk of safety, they talk of ISOs. I also know with cyber security, they also talk of ISOs, information security. Okay, I'm not so familiar with ISO, but I think there is a standard information security management, what management systems. I think so. So ISOs, they're more related with safety, quality of the telecoms, manufacturing industries, engineering. Right. So those are the standards organizations which are responsible for WAN standards. Right. Once in the OSI module, so wide area networks, they are in their protocols, they're basically in layer one and layer two. With layer one protocols, we have SDH, SONET, and DWDM. Is that the protocol? We have division multiplexing. Then layer two, we have broadband, DSL and cable, wireless, Ethernet WAN, multi-protocol, MPLS, triple P, HDLC, frame relay. Okay, we no longer use that one that much. Then ATM. So those are some of the protocols, but basically layer one and layer two. With Ethernet, I think Ethernet, it operates in both instead of only one layer. Let's go. Common WAN terminology. All right, there are specific terms used to describe WAN connections between the subscriber and the service provider. All right, starting with DTE, data terminal equipment. So connects the subscriber lines to the WAN communication device. So the DTE, these are the devices that generate traffic, basically. It generates and processes traffic. It also consumes data. So these are your end devices, your computers, your phones, your printers, your end devices, those that generate data, right? Those are your DTEs. Then we have our DCE, the device used to communicate with the provider. So our DCE, these are the devices that provides the physical connection to a network, right? For example, routers, those are your DCEs. Your modems, those are your DCEs. So from this diagram, I have my, okay, running out of time. From this diagram, I have DTE. Okay, it's highlighting a router there. I don't think a router is a DTE anymore. It might be, I'm not so sure. But I can put a router as a DCE, all right, data communication equipment. Then I think it can act as both. Then we have CPE, customer premises equipment. This is basically a sum of those two, the DTE plus the DCE. All right. These are all the networking equipment located on the customer side, on the everything on the customer side. So it's like we are separating. You can see there is a demarcation there. We are separating the customer side, then the service provider side. So all the networking equipment on the customer side is called the customer premises equipment. I think it defines itself. So it's a sum of the DTE plus the DCE. Then we have a POP, which is the point where the subscriber connects to the service provider network. and the demarcation point, the physical location in a building or a complex that officially separates the customer premise equipment from the service provider equipment. So you can see there is our demarcation point separating the customer side and the service provider side. So left side, customer side done. We have the DTE, DCE, CPE, and our POP. Right, then on the other side of the service provider, we start with the last mile, the local loop. This is the copper or fiber cable that connects to the CO. So the local loop, the connection between your CPE, your customer premise equipment, and the local central office. That is what we call the local loop. I think uh, as of today, I think that local loop is more dominated by fiber instead of copper. It's more fiber than copper, I think. Then we have the central office itself, the local service provider facility or building that connects the CPE to the provider network. Right, so the CO connects the local loops